Greetings! Today another wireless charging item, and that's the third of my lot that I got, and this one is a receiver. So this you're meant to insert into your phone under the battery cover next to your battery, and it will equip your phone with wireless charging capability if it hasn't got one already. Now this specific one is made for Samsung Galaxy S4. I got this off of eBay, off of the same seller. We'll look at the listing in a moment, but the model over here doesn't matter. I want to see what's inside and how is it different from the transmitter, I guess, and the receiver, and we'll compare the two, see how that works, and then test it maybe. The whole receiver is very flat, so it can fit inside your phone next to your battery. It's got one connector here at the very end, and the whole thing is sandwiched between two pieces of what feels like it's just some sort of metallized plastic, cellophane maybe, or something along those lines. So if I can feel inside, you can possibly see a little bit in terms of a reflection. We've got a coil over here, and on this side there is a PCB in here somewhere, a little bit. It's a little bit stiffer on this side. So let's have a look at the listing first, and then we'll take this thing apart. It cost me 89 pence this Hot QI wireless charger charging pad receiver, new for Samsung Galaxy S4 i9500. Item number is 371720322407, and it came from the same seller, VV seller 47351. Okay, let's have a look at what sort of voltage this puts out. So I've got this connected to a multimeter set to 20 volts, and the charging pad or transmitter I've got connected to this USB power monitor, so we can compare the two, what's happening. So as before, in standby is drawing just under 10 milliamps if anything. And hold on, my crocodile clips are slightly disconnecting. There we go, we've got 4.9 volts on the output, and the unit is consuming, well, 390, 400 milliamps at 5 volts, as you can see. So yeah, that's that power goes nowhere. I'm not drawing any current out of this, and this is roughly about 2 watts of energy just to keep this going, just for this to communicate. It's not getting any power output out of it actually just yet. So let's see what happens when we put a little bit of load on this. And there we go, here's the setup. So I've got the receiver on the transmitter being held with a pack of screwdrivers. That shouldn't make a difference, the most of it is plastic at the bottom. And we've got this monitoring the power. Now I'm not drawing any current just yet, but it seems to be drawing about half an amp, so a little bit more than just a moment ago. And this will slowly increase the current load on this using my DC current load. And here we've got the current that we're drawing out of it. So let's begin increasing, and I'll try to keep it so it's in the view. 100 milliamps, and we're drawing just about half an amp. Yeah, let's go up a little bit. 200 milliamps. $400 milliamps. At half an amp coming out of it, the transmitter is consuming 1.39 amps, which is quite a bit. Let's go to the nominal. Oops. It seems I was trying to get to the nominal 800 milliamps, but it's not having it. So I'm going up slowly. 610, 640, 650, 660, 670. Okay, 680, and it cuts out, and it basically disconnects. It says too much power, so let's try again. Oh yeah, it doesn't even want to go to 700 milliamps. One more time. Right over here, it seems it can sit indefinitely. 680. Oh, there we go. We've got 700 milliamps. Now, as soon as I touched it just a little bit more, it cuts off and it disconnects. Now I'm having a feel on the transmitter, and it's noticeably warm where the PCB is, not the coil itself, but actually the coil itself as well. So let's actually open this quickly and see what's been going on inside. Yeah, both the coils and the MOSFETs are quite warm actually. So yeah, we have been pushing out a little bit too much out of it, but still this was putting about 1.5 amps through this coil, which can produce some temperature. It's not 800 milliamps, it's 700 milliamps at most, and that's actually a little bit of a stretch. But anyways, let's take it apart right now and see what's inside. So to begin, I'm gonna try to be gentle, and that actually comes off quite easily. Okay, coil is not round but rectangular in shape with rounded corners, and there's significantly more turns on this compared to the transmitter coil. There we go. We've got the charger out. So that is the PCB that was inside, and what we see over here, to the left we've got a 6-pin device marked S42BGB, Bravo Golf Bravo, whatever that is, I'm not sure. Then we've got this mysterious 10-pin device with no markings whatsoever, and very dodgy looking package. And yeah, that probably is some sort of micro doing the handshake and communication with the transmitter, but it's a little bit unspecified of what it actually is. Here we have 4 what I think are transistors, marked A2SHB, 2 diodes, probably Schottky diodes I would think, and a couple of passive components, capacitors, resistors and whatnot. Here's the coil of the device, and you can see they've used 2 wires to make the coil up, but the wires are not going in side by side. They're going in well, side by side really, but in flat wise, if you know what I mean. You can see that over here on the screen. That's to keep the coil as flat as possible, and at the same time increase the current capability of the coil. And I've counted the turns on this coil, and it turns out to be 34 strands of copper going across. Now, because there is 2 wires, that means it's 17 turns to make up the whole coil. And here is the end coming off of it, and you can see the 2 wires next to each other. That's basically just one conductor. And let's have a look at the dimensions of the coil. So it's gonna be a little bit more because it's not round. So long wise it's 34 millimeters, and short wise is 29. We can call that the inside. Short wise is 11, and long wise 16.5. And the coil itself is made out of wire of thickness, I guess that's 0.35, 0.36 millimeter. If you were wondering what's inside one of those, now you know. And yeah, I'll be saving that for further experiment. As far as this video, I think I'm gonna end over here. So thanks for watching, give me a like, thumbs up, and yeah, subscribe for more random stuff if you find it interesting. For the time being, take care.